All right, so complex numbers. In the first unit, we were dealing with real numbers only. In the second unit, we're now going to deal with what are called complex numbers. And so a little mini review on this. I know you guys have seen this before because you were wanting to answer these on the first unit. But I squared is not a variable. It's called an imaginary number. And it is the number whose square is -1. Now you might be wondering, if it's imaginary, why do I have to study it? Well, in math, there are a lot of things that imaginary numbers have to do with the further you go in math. And in physics, apparently, I don't know physics, but I am told that there are applications that have to do with complex numbers as well. So we do go ahead and learn about them in college algebra, because a lot of students are going on to other classes where they might use those more. Okay, so it is the number whose square is -1. So it's not a real number. It's a different kind of number. And let me rewrite this. That means that anytime we see square root of -1, we are going to replace that with this number I. Okay, the standard form of a complex number looks like this: A plus B times I, where A is a real number called the real part, and B is a real number called the imaginary part. Not that you have to remember that, but you know you're finished working with complex numbers and simplifying when you can tell what A and B are. Okay? If you are going to take pre-calculus algebra, because you're going to eventually take calculus, you might want to look at the rest of the notes. Remember, the key is there. And so you can look at the multiplication between complex numbers and addition and all that. It's not real hard or anything. It's just that we don't have to do it, so I'm not doing it this semester since I had to miss a class. So we ready? Okay.
Can you go back a little bit?
Oh, go back? Okay.
You're good.
You ready? Okay. Now, anytime you have the square root of a negative number, you're going to need to factor out the square root of -1 and replace it with I. That's just part of simplifying. The next statement here, you guys don't need to write down this semester because we're not really dealing with the operations. So I'm just going to go to some examples that are important because we are going to be working with the quadratic formula. And so you're going to need to remember how to simplify with these radicals. So here's the first one. Square root of -9. I'm going to rewrite that as the square root of 9 times the square root of -1. Remember, if I'm multiplying, then it's equivalent to put those together under the same square root or to separate them if you're multiplying or dividing only. Then, of course, you're going to write what the square root of 9 is. That's 3. And then the square root of -1 is I. And so now that is simplified. So the little bit of homework that you've got in the complex numbers is practicing towards using the quadratic formula, which is a little more complicated, and knowing how to simplify. Okay, let's look at this one. 6 minus the square root of negative 81? Yes, you're going to call that 6 minus the square root of 81 times the square root of negative 1. So that is 6 minus 9i. Now put a little asterisk here. This is one of those little things that when you're studying, bless you, when you're studying for a test, you want to pay attention to this. Remember your order of operations. Everybody remember their order of operations? Okay, this is a product. This is multiplication. That's the M. You do M before you do add or subtract. So you don't put these together. You don't write that as negative 3i. It should stay like that. Okay? That's going to come up in another situation as well. Like if we have a square root left here, we don't want to put these two things together. Okay? That's a very common mistake. It's just, I think it's because we read from left to right and sometimes we don't think about what we're doing. Okay, so square root of negative 810. I'm going to break that up as square root of 81 times square root of 10 times square root of negative 1. I'm just breaking up the 810 as 81 times 10 because 81 is a perfect square. And 10 can't be broken down anymore. It's 2 times 5. This has perfect square factors. There we go. So that is 9 square root of 10i. That would be your final answer there. But please be careful not to put the square root symbol over the I, because that's wrong. Okay, make sure the I is clearly outside of that. How many people remember the quadratic formula? A few people, kind of, sort of. Okay. This next one should look a little to you like an answer you might get with the quadratic formula, which we will be practicing on Thursday. 8 plus the square root of negative 20 all over 6. We're going to simplify. And this is actually the last thing we're going to do in this section. We're going to get a little bit into the next one, I think. Okay, you guys ready? All right, so 8 plus 20 breaks down as 4 times 5. So I'm going to think of that as square root of 4, square root of 5, square root of negative 1. All over 6. What am I doing? I'm pulling out the perfect square factor.
So if like the square root doesn't work, you always like break it down to ones that multiply to get.
Oh, you mean, okay, when you say doesn't work, you mean when it's not a perfect square.
Yeah.
Okay. Yes, you always look to see if it breaks down. Now, because she asked that, let me just give a little sidebar here, okay? What if it was just square root of negative 6? The only thing I would do with that is pull out the square root of negative 1, because 6 doesn't break down anymore. It doesn't have any perfect square factors. It's 2 times 3. So that's square root of 6i. That would be the only thing you do with that one.
Okay.
But the 20 had the perfect square factor, so we have to pull it out. Okay. So that is 8 plus 2 square root of 5 I on the outside of that radical over 6. There are so many pitfalls in the simplification process with the quadratic formula. Let me show you what is pretty much foolproof. Okay, there's 2 ways to deal with this. But what some students will do is they'll cancel just one of the numbers from the top and then they'll get the answer wrong. So the foolproof way is to just always put both of the denominators separately. That is, if you get in that habit, I don't think you'll make a simplification error. And we can put that I just kind of out to the side of that fraction, okay? But there's a plus. So it's got to be every part of the top over the denominator, not just one of the terms. And then you can see how to simplify, and you can use your calculator. Yeah?
Can you just do divide by 6 in the beginning and then go ahead and do the square root 20? That's what I was taught.
I don't understand what you're saying.
Instead of before doing, you know how you just did the divide by 6? They told me in the beginning, do divide by 6 and then go ahead and do square root 20 and get the 4. That's how. Like, focus on the 806 and then do the.
Oh,
yeah.
do this part up there?
Yes.
Yes. Yeah, absolutely. You could do that first. Okay, and then that reduces to 4/3 plus, and of course with quadratic formula we're going to have plus minus here. And then 2 and 6 cancel. That's square root of 5 over 3i. So that's correct. Now, if you were taught to factor, if you factor out a 2 on the top, was anybody taught to do it that way? No? That's the only other thing that's really correct. If you factor and cancel, that's correct. So if you factored out a 2 on the top, you see it? Those are actually, I just want you to see that these are equivalent. 4 plus square root of 5 times I all over 3 is the same thing as what I wrote over here. See how, if we went ahead and separated it, it's really the same. Okay? So either of those is acceptable. But getting into the habit of doing it this way is a good idea, especially people that are going into pre-calc, because they'll have to work with complex numbers some, and maybe in trig too. Sometimes you have to work with them there. And that's the correct way to write a complex number, while this is not actually the correct way to write it. That's the A plus
Which
BI.
way will the computer?
It will accept both. Okay? So if it marks you wrong, you did something wrong. You're doing some sort of simplification wrong,